So, hi, my name is Konstantina Tsioli. I'm the Digital Transformation Unit Leader from CORE. And this is the last panel discussion for today's agenda. And we're going to discuss about the mining industry and its transformative journey towards the digital era. So the mining industry is one of the most significant contributors to the socioeconomic landscape of EU, and it's considered to be also a cornerstone for the industrial progress. However, at this point, it's at a pivotal stage as it faces a lot of pressure to become more sustainable, more resilient, and more efficient. And these pressures arise from mainly the global demand, the increased global demand of raw materials, the declining ore grades, and sustainability imperatives, and of course the rising standards of production. We need to overcome these challenges. We will need innovation, technologies, a strategy, and of course we will need robust data, which bring us to the digital transformation process. Now I'm happy, I'm joined today by 5 distinguished experts from EU who are going to guide us to this discussion. First of all, Antonios Pepas, professor from NTUA, with an expertise in sustainable energy operations and the participation in over 30 EU initiatives. José Ramón Valdés, from head of European projects from Itainova, with a leading experience of more than 20 years in this field. Kostas Botsialas, founder of Aurora Geo Consulting, with extensive specializing in geohazard mitigation and mining safety, utilizing several innovations. Santiago Cuesta Lopez, General Director of ISMC, leading activities in raw materials innovations and presence international and EU collaborations. And finally, we have Emilis Vazoukis, exploration geologist from Ternamag, with expertise in geological mapping and resource exploration. So I will start with you, Emilios, from the demonstrator, from the end user side. And yes, I would like to begin about what does digital transformation mean to you as a demonstrator, and what kind of difficulties you have faced so far?
Thank you very much. Digital transformation in the mining industry focuses on improving safety, sustainability, efficiency, and reducing costs. As a mining company, digital transformation involves shifting from traditional manual processes to automated data-driven systems that use real-time information to optimize operations. However, challenges like outdated systems, data management, and workforce adaptation can make implementation difficult. Overcoming these challenges requires strategic investments and a long-term commitment to change. Thank you.
Thank you. Thank you, Emilios. So, but from the mine aspect, of course, the major target would be to increase the output, which means the raw materials, of course. And by that, what I wanted to connect, I wanted to take into account the CRM Act, because it gives us a hint about how important is the critical raw materials. And it's important to consider that by 2030, we need to satisfy 10% of the CRM EU needs with domestic productions. Now, usually, before any of these exploration activity, we need to have feasibility studies. So this comes to you, Kostas, with the experience that you have. You have demonstrated in geohazard mitigation. Could you explain us more about the geohazard management and the associated technologies to enhance the accuracy and the efficiency of these exploration activities?
Thank you, Konstantina. First of all, congratulations to you and your team for this exceptional organization of this event. congratulations to Stefanos and Nikos for this initiative. Well, exploration is a field in geosciences where geologists and earth scientists are trying to find the ore body. They're trying to find where the money is. Okay. And of course, part of this process is to find out the best possible scenario, the best possible design in order to get most of this material, either open pit or underground. Now, part of this process, a very important part of this process, is to know if this design is viable and if this design is sustainable in terms of that it can work for a long term without any problems from any kind of geohazards, collapses or landslides or rock slides or things like that. So it becomes more and more important as time goes by, and unfortunately as events are happening around the globe, with failures that are happening in big or small open pits or underground mines, that we have to take care of the designs. We have to test if these designs are good enough to provide sustainable production for some years. Mining is not a business that is having a cycle of some years. It can have 20 years, 30 years, 40 years, or even more. So we have two main groups, two main aspects. We have the greenfield aspects. It's when nothing is in place before any mining takes place, where people are trying to find out the ore body and to visualize the design. And there it's important to validate that this future design is good enough to provide enough money, at the same time to provide money in a constant flow. And then we have the brownfields as well, where there was mining for a big or smaller period. This mining stopped for various reasons, and now they have to start it again. And in these cases, we have to be sure that the new start will be safe enough in order the production to continue again in short and long term.
Thank you. And these technologies, of course, when they are combined with a 4.0 mentality, they are the enablers. So we gather this information and we gather them into an interconnected ecosystem. And with this ecosystem, we get to have more the ability to monitor, to leverage the insights, to understand what's going on inside. So I would like to go to you, Jose Ramon, about what are the key challenges in implementing a fully connected ecosystem, sustainable mining ecosystem.
Okay. So thank you very much for inviting ITA to this event. ITA has coordinated the DIGIT project in Horizon 2020, and now we are coordinating the Mastermind project in Horizon Europe. And based on our experience in those projects, we can say that, yeah, it is clear that the implementation of digital technologies, such as digital twins and the associated systems, pose a challenge. Rather than in the technological development of those systems, the challenge, which are being used to some degree of maturity in different sectors, the challenge lies in the integration of those technologies in the mining sector. We have seen that there is a lack of IT infrastructure, of electrification and automation of machines, of communication network, sensors, and even also lack of prior data with which to build reliable data-driven models. So those are some of the challenges that we have identified and addressed in projects like DIGIT and Mastermind. So things like the lack of connectivity inside the mines can be addressed by installing networks of range extenders, for example. More crucial is the harsh environments that are found inside the mines that affect critically the durability of the sensors. For example, in one of the Digit mines, the sensors were ruined only after 1 month of operation due to the presence of dust, humidity, contaminants, chemicals in the air. So it is needed to install robust and redundant sensors that have to be protected against these harsh conditions. In this sense, sensors are crucial to retrieve data from humans, from assets, and from the environment. And at the same time, data is, the retrieval of data is critical, not only to display information in real time, but also to build these machine learning or AI algorithms that must have the capability to predict things like operation anomalies or collisions or failures in assets or risky environmental conditions for workers. On the other hand, this lack of data or sensors can be complemented or can be circumvented through the use of the so-called physics-based digital twins, which have proven to be very useful. An example of such physics-based digital twin can be an air quality digital twin, which is based on CFD simulations of the airflow inside the mines. And these CFD simulation models generally are very computationally costly and take a lot of time to run, but you can convert them into reduced order models that can run in real time. So one example or one application of this in Digit was a marble quarry in Italy where we deployed a digital twin of air quality that provides in real time maps of temperature, velocity, and residence time of the air inside the mine. And also the good thing is that because this mine is ventilated by natural convection, you can use the data from a weather station that is located outside to provide in real time input parameters for the digital twin. Another application of a physics-based digital twin would be ventilation by demand, which can help increase the productivity. Well, it can help to reduce the costs, energy costs associated to the ventilation systems, and can help increase the productivity of the mine by reducing or optimizing the standby times that are allowed after ventilation. An application of this was a mine in Finland where forced ventilation is applied after the blast to remove contaminants and chemicals after the blast, and also from the diesel-powered machines. One challenge here, I have to say, is the characterization of the contaminant sources, because you need sensors in the diesel machines to characterize the emission of contaminants from the machine, and also you need to have data from explosion tests to characterize the emission of dust, chemicals, contaminants from the blast, because modeling the blast itself would be extremely challenging. But yeah, those would be some of the challenges that we have encountered.
There are exciting opportunities here, and thank you for your response. So, yes, it is a hard environment. These are big news for it. And with this connected ecosystem, we have the opportunity to address one of the biggest concerns of the mining industry, which is the environmental impact. And I'm wondering if it's too much. So, Adonis, given your expertise in energy operations, how can Industry 4.0 technologies like digital twins and IoT can help mining companies to address these key environmental challenges while achieving the targets that they have set?
Okay. First of all, I would like to thank you for the organization bringing together research teams, universities, and industries, and experts on AI. I think the next theme for next year will be quantum AI. Keep it. I have to say at the beginning that the mining industry, it was a dumb industry, and it squeezed, let's say, to produce more in a day-to-day difficult environment. What I'm trying to say with that, In the last century, the grades of copper deposits have a concentration about 8 to 9%. Today, they have 1%. So the waste from the past will become deposits on the future.
True.
And inside this competitiveness environment, the European, mainly, extractive industry should reduce the emissions. And on your question, from lower level to higher level, let's start for the need for monitoring data. A real situation for the market. As a university, we're in close collaboration with the industry. Last year, Aluminium of Greece obtained environmental product declaration for all the end products. This means that you have to analyze the complete flow sheet of the industry to make a balance, a mass and energy balance. This means a huge amount of data in order to collect every year and in order to revise annually your environmental product declaration. So, based on the green transition and the need for all these certificates and the passports, you need a lot of data. Let's go to a higher level, to the analytics of the data. We have the closure of the mine. The mine is not like the conventional industries. You turn off the key and you leave it there. You have to maintain all your facilities and to monitor the environmental conditions after many, many years of the closure of the mine. One specific example, Hellas Gold. They have the tailing dams. After the end of the closure of the mining, they have to monitor the tailing dams to monitor the stability, the possible flooding conditions, etc. This means continuous data collection from Copernicus and on-site sensors in order to ensure the stability of the dam and to avoid any possible flooding. Another issue from, let's say, opportunity for collecting data is the social license to operate. A good example is also, again, Hellas Gold, that all the data monitored from the waste streams and the tailings are issued in a website and provide all this data to the community. This means that they bridge a social, let's say, license to operate and give the opportunity to the society to understand that the whole facility performs in an efficient way. In more higher level, we have a new initiative now, the Primrock project, started a few months. The concept is to decarbonize the extractive industry by using hydrogen technologies and electrification. But the major difference from other projects here, it's a lighthouse, is to build a pipeline from the extraction to the quality of the end product. Why we are saying that? Because the deposits are many, many minerals inside with different concentrations of metals. This means if the concentration of the minerals and the quality of the mineral site deposit changes, you have to change the whole procedure in order to ensure the final, let's say, value you need for the end product. This means that you have to not simulate, to build simplified models, and based on the data to train these models, because there are many, many parameters inside that, in order to identify the mechanical preparation needed for your deposit, for your ore, how this will be fed to the next process, which usually it's a high temperature, let's say, process, and inside these processes, how the main parameters will affect the end product. This is the target of the Primrock project, and we believe together, all the consortium and the core, we will manage to have, let's say, the first project that the data are gathered from the beginning. They are tracing the major, let's say, processes, spots on the process that should be monitored, and to efficient adjusting them in order to maintain the minimum environmental footprint.
Thank you. Undoubtedly, it's a really difficult equation to solve here. You said about informing also the community, which is really important. But what I wanted to say is that in order to ensure that, to accelerate, firstly, the digital transformation and furthermore to safeguard its success, we need also to engage other parties as well. We need to bridge the gap between the research institutes, the industries, the end users, and the stakeholders, the policymakers. So, Santiago, what kind of strategies do you think that they should be employed to safeguard this success?
Thanks, Constantina. Let me first join to the global compliments for the event. I think it's been a really, really great success. Also, I am very happy to have been invited. I'm very grateful. I'm very happy to see familiar faces here. We are beginning to be like a community, an ecosystem. And this kind of ecosystems of innovation is the answer to the question that you were raising to me. So we are working at European level in the creation of innovation ecosystems, resilient, neutral zero, highly digitalized innovation ecosystem in raw materials. And in raw materials, there is a specific advantage. The raw materials are endogenous resources, so they belong to the territory. And that's where exploration technologies, exploration techniques matter. Projects like the Explore, we are coordinating. Projects like TerraVision, we are partners together. So the idea at the end is to create a knowledge of what we have under Earth, which is our patrimony in our regions. So at European level, in order to boost all these kind of global communities or global advances for being resilient or for making the European industry resilient, we have created a collection of ecosystems of innovation that we have associated in the International Mining Region Network. A network that here in Greece is represented by NTUA, by the group of Professor Paspariaris, Charcou, and Professor Pepas. So all Greece is involved here, although there is a clear stakeholder representing. And we are joining these mining regions across Europe, and there we are creating these ecosystems of innovation where we are involving the quadruple helix. That means, as Professor Pepas also mentioned, the importance of universities, competence centers, technological centers like ITA Innova, like the center I represent, clusters, as Iberia Sustainable Mining Cluster, stakeholder groups, the governments. And the masterpiece of all that is digitalization. So with digitalization, we can implement digital innovation hubs to train, to promote, for creating innovation procurement activities like core innovation. The same thing that you are doing is one of the most important points, innovation procurement in an innovation ecosystem. And in mining and in raw materials, this digital renovation or innovation that we are promoting is focused on the exploration of new resources, social license to operate, augmented reality, training to the workers. It's very important now to train the workers to the new systems and to the new era. Protection of the health of the workers. There is where, for instance, the digital twins matter, because you can control not only all the robots or the machines that are in the mine, you can also control the exposure of the workers to nocive substances like the silica, which there is a new European role that all the silica is now cancerous. So we have a very important problem of modernization of all our quarries and on all our mines. So it's not only to improve the production, it's also to make the production safer for the workers and more sustainable for the environment. This is one of the key points that all these digitalization hubs, this innovation procurement is going to help to the objectives that you were mentioning about this 10% production, which is the master goal in the Raw Materials Act that we have to respect. Thank you.
Thank you very much. We are approaching at the end. I was wondering if you wanted to state in one word, like the most significant barrier for achieving widespread adoption, beginning with you, Amelia, if you want.
The main barrier to adopting Industry 4.0 technologies in mining is the challenge of integrating outdated systems with modern solutions and the skill shortages. To address this, stakeholders should develop scalable and cost-efficient technologies, invest in workforce upscaling, and foster a culture of innovation.
Okay.
So, these efforts can accelerate digital transformation, making mining more competitive and efficient.
Thank you. Santiago, a word? And
well, just to summarize again, no? I think it's very important that we use all these digital twins technologies for all the challenges. We have defined it in some of our European ecosystems, the top 10 challenges that the European mining industry must respect: sustainability, digitalization, robotization. So all this is in the core of the core innovation days, and I think we are in the path.
Perfect.
Yes, I think the main challenge is that people who are working in the mining industry should be coordinated with the new evolution that's coming from outside, because the greatest proportion of Industry 4.0 production in terms of ideas and innovation, all this stuff, comes out of the mining industry. And people who are working in the mining industry, many of them are not well trained to get this, to accept these innovations. And of course, unfortunately, and especially for the Western world, there's a huge shortage of people who would like to work in the mining industry.
Yeah. True. Thank you.
Yeah, so based on our experience in these projects, I would say the main barrier is creating the right ecosystem for the adoption of the technologies. That means IT infrastructure, connectivity, electrification, automation, and very critically robust and redundant sensors, because data is essential not only for monitoring information, for building machine learning or AI algorithms, but also for the validation of the physics-based simulation models, for the characterization also of sources for these models, and also for giving input to these models. So I think projects such as the European funded projects we're talking about are helping to create this cultural shift that is required in the sector for the adoption of these digital technologies.
Thank you very much. And a really, really quick word.
Open-minded investors, proof of concepts in specific areas, and funding. You cannot find available funding for AI applications or digitalization applications.
Okay, we'll go on and talk about that. I want to thank you for this panel, and thank you all of you. I would like to welcome to... okay, yes.